Let's talk about combinatorial binomial convolution in detail. A convolution of two sequences, say an and bn, is a star b of n, which is nothing but summation ncr a n minus r br. R goes from 0 to n, is also equal to this is the definition of a convolution, where it's also commutative. Now, the definition of the function for one-dimensional rook is said to be 1 by L minus 1 power n plus theta L minus 1 times minus 1 power n, where L and theta are the parameters. Theta is 0 when the walk is open, and theta is 1 when the walk is closed for a rook. So R1d of n is a function with parameters L and theta. Now, if Rkd of n is a function defined as number of ways a rook can traverse from one starting point in k-dimensional board to the ending point in a k-dimensional board, say you have x1, x2 till xk, and till y1, y2 till yk. These are your starting points and ending points, and theta 1 is defined as 1. Theta I is defined as 1 if xi is not equal to yi, and 0 is 1 if xi is equal to yi, and 0 if xi is not equal to yi. If theta I is 0, then the walk is open, which means the starting and ending destination is not the same. And 1, theta I equal to 1 means the walk is defined as the walk being open. That means xi equal to yi. The starting and ending destination of that component is the same. That means, so in this situation, if this is your definition, then assume p plus q is equal to k. Then one can say that xi, x1 till xp, then xp plus 1 till xp plus q, 2 y1 till yp plus 1 till yp plus q in n moves. Then assume I take r moves that I in one of the moves, one of the possibilities, I take r moves to move from x1 xp to y1 yp. Since each move only one component of these can be changed, so assume there are r moves in which x1 to xp is changed to y1 to yp, and there are n minus r moves in which that xp plus 1 to xp plus q is changed to yp plus 1 to yp plus q. In such a case, one can write this as with a fixed sequence. Assume the sequence is fixed, then you have rpd of r and rqd n minus r such possibilities. With fixed sequence, that means first r moves will be from x1 to xp to y1 to yp, y1 yp, this tuple, x1 to xp a tuple to y1 to yp a tuple, and then this tuple to this tuple. Now, number of ways one can arrange these r moves and n minus r moves is n factorial by r factorial n minus r factorial, because we can categorize this as a p move and a q move. There are r p moves and n minus r q moves. Now there are ncr ways to arrange these r p's and n minus r q's. So we have ncr, r pd, r qd, n minus r, and one can write rkd as summation r equals 0 to n summation r from 0 to n ncr rpd of r times rqd of n minus r. So that means rkd of n is nothing but a convolution of rpd star rqd of n for all p plus q equal to k, and p and q belonging to natural numbers less than k. Yeah, there you go. Natural numbers 1 to k. So that gives you rkd of n as rk minus 1d convolution r1d, which is nothing but ncr r equals 0 to n ncr r k minus 1 d of r times r1 d n minus r. Now let us define a sequence of functions fi of n as mu. So this basically means where okay. Now I am defining fi of n as a finite summation of exponent functions. So one can also write this. So if I say say h of n is equal to alpha 1 beta 1 power n plus alpha 2 beta 2 power n, then this fits the category of fi, that this h of n can be a sequence under fi of n. This is a valid example of fi. So one can also write, for understanding, you can also write fi of n as phi mu e to the power gamma I mu times n. Yeah, that's right. Using exponent function, I can write this as ln at gamma I mu as ln beta I mu, and you get the following. So it's just a sequence of fi is just a linear combination of exponent functions. Fi is a linear combination of exponent functions, which I will be using this notation instead of this notation. I will be using this. Now, now let's use the convolution operation on a linear combination of exponent functions. Now fi star fj of n is nothing but summation NCR, and here SI is a sequence of finite subsets of integers, which means that if SI is 1 and 2, 1 comma 2, then you have alpha 1 plus alpha 2. So you have SI as a set of 2 elements. That means it's a summation of 2 elements. Okay. Now you have you get the following. The product of this and this is nothing but using distributive property of multiplication, you get mu belonging to Si and nu belonging to Sj, alpha I mu and alpha j nu. This is j, by the way. Alpha j nu beta I mu power r beta j nu power n minus r. I can bring the NCR inside and the summation as well. I can interchange the summations. You get the following. This is nothing but which one can write it as the cross of this. Now, what about convolution of fi star fj star fk of n? Well, in such a case, you will get summation mu1 mu2 belonging to si star sj comma mu3 belonging to sk and alpha I mu1 alpha j mu2 alpha k mu3 times beta I mu1 plus beta I mu2 plus beta j mu2 plus beta k mu3 power n, which is again nothing but mu1 mu2 mu3 belonging to si cross sj cross sk alpha I mu1 alpha I mu2 alpha j mu2 alpha k mu3 times beta I mu1 plus beta j mu2 plus beta k mu3 power n. Inductively, one gets that f1 star f2 till fk star fk of n will be mu vector, where mu vector is mu1 till mu k belonging to s naught, where s naught is a cross of s1 till sk and this will be pi times alpha I mu I belonging to 1 to k times summation I belong to 1 to k beta I mu I. This is your convolution. Now, here for fi equal to summation alpha I mu beta I mu power n, mu belong to si, replace si as 1 comma 2 for all I and alpha I 1 as 1 by li, alpha I 2 as 1 by Li times theta I Li minus 1 beta I1 as Li minus 1 and beta I2 as minus 1. Substituting all of this will give Fi of n as 1 by Li minus 1 power n plus 1 by Li theta I Li minus 1 times minus 1 power n. This is your Fi of n. Now, RKD is nothing but a convolution of F1 star till Fk star Fk of n in this scenario. Now, in this formula, which we get as summation mu belonging to S0 times pi alpha I mu I times summation beta I mu I, simply take 1 by pi Li, I goes from 1 to k, mu belonging to S0 times Li alpha I mu I times minus k plus 1 plus 1 to k. I goes from 1 to k, 1 to k, 1 to k, 1 plus beta I mu I. I've added 1 and subtracted 1, and I have multiplied Li and divided Li. So this remains unchanged. This is the same as this. Now, assume if mu1 is 1, then you have Li alpha I mu I as one. But if mu1 is 2, then you have Li alpha I mu I as theta I Li minus 1. And you also have beta I mu I, 1 plus beta I mu I as Li, and in this case you have 1 plus beta I mu I as 0. Okay, now assume that for S being a subset of n of k, where n of k is numbers from 1 to k, integers from 1 to k, assume that mu I that mu I is 1 when I belongs to S, and mu I is 2 when I does not belong to S. Assume this. That means for mu belonging to S naught, and we have S being a subset of nk, or S belonging to power set of nk, we have S being a subset of nk, and you can divide this as I belonging to S of nk minus S Li alpha I mu I RKD is of n is this, and I belonging to S Li alpha I mu I. Also, this multiplied by minus k plus I belonging to S 1 plus beta I mu I plus I belonging to nk minus S 1 plus beta I mu I. So I have split I belonging to 1 to k into whether it belongs to S or whether it does not belong to S. Now we know when I belongs to S, Li alpha mu I is 1. So this whole term is 1, and this is 0 when alpha I is 2. When I does not belong to S, when I does not belong to S, that means alpha I is 2. That means mu I is 2. That means this is 0. This is 0. So that means this whole term is 0. So you get this following as S being a subset of nk and this is nothing but theta I Li minus 1, and this is nothing but Li. So you get pi of I belong to nk minus s theta I Li minus 1 times summation minus k plus summation I belong to s Li power n 1 by pi Li. Of course, 1 by pi Li we forgot. 1 by pi Li. I belong to nk. There you go. R K D is nothing but 1 by pi Li I belong to n of k times summation s, a subset of n of k, times pi theta I Li minus 1 I belong to n of k minus s times summation Li I belong to s minus k power n. This minus k is outside the summation. Okay, there you have it. This is your RK of D. It is nothing but the following.